So everything what I'm doing, I try to share knowledge, but not only online. I'm also connected with some universities. So everything what I'm doing right now, I try to promote how to automate work in the AAC industry. Jungfu Park, my guest today, I will introduce. I'm really happy to collaborate architect with engineering skills. Are you feeling more as an architect or engineer, Jungfu?
Definitely architect.
Architect. Jungfu is a Revit expert, VDC manager. This year, he's been presenting Grasshopper at the Autodesk University. So I'm going to also speak about that, and maybe you can also share some experience. McNeil course or tutor for many, many years, and having a YouTube channel, Spot, for sharing all the knowledge, showing a lot of Grasshopper inside Revit. So Jungfu was in the Autodesk University this year. It was in Nashville, right? Was it in October? Yeah. And Jungfu presented for the first time Grasshopper at Autodesk University. So it was really historic moment. How was your experience? How many people were on the laboratorium?
So in total, there were 73, and 60 people could sit on the laboratory, and another 13 was behind backstage.
And just standing with computers.
No, they were sitting behind. There were some chairs prepared, and also special guest from McNeil Associate, Jappy, was supporting me, running around, and was really great help.
You can maybe tell a few words about the events that you've been part of. You've been doing a lot of workshops for now for McNeil. Maybe you can also say a few words.
So I'm architect from South Korea, and I've been running Rhino.Inside Revit workshop since I think 2020. So about 5 or 6 workshops we are running, and also this year December we are running. And during this preparation of the workshop, Rhino.Inside Revit developed so much dramatically since 2020, as soon as Rhino 7 was launched. And all the discovery and also community feedback from the forum, I collected and somehow customized and personalized and made an educational package. And Chris was invited me to collaborate as a recorded tutorial, which I had never done it before. So we prepared quite good set of tutorials, structured tutorials from the beginners level to some of the advanced topics. And today we're going to unveil some of the topics, use cases, and we collected from Rhino.Inside Revit users who.
So it's really if you want to see it, so just wait until the end of this workshop. So we are going to unveil some of our work, and you are also representing DOCA, right? You've been working there.
Yep. So I'm BIM manager at DOCA Corporation Engineering. We've been working large infrastructure project to any kind of building and infrastructure. And as you can see, as a former engineers, we have to deal with higher level of detail that really deliver all kind of design to fabrication onto site to build it. And I know that formwork is temporary structure, so we have to even think about logistics and also disassemble and recycle full life cycle of the process. And BIM and computational process is really key, essential element for those workflows.
Yeah, great experience. As you can see, many tutorials, also live experience from using Rhino Grasshopper in Revit. So let's go to today's presentation. As I showed you at the start, agenda was not created by us, but we asked more than 4,000 Revit users what hurts most. And this is the 6 points that we got most of the answers. So first, endless parameters edits. So Revit users really lose a lot of time on that, not just sending editing once, but hundreds of times, and this is where money on the projects are lost. Slow bloated models. This is also something like Revit struggle most, creating families at the scale, not by one, creating views and sheets and drawing and dimension. This is also like most 50% of users said that most of the time is going for the editing views and sheets. Naming chaos, not organizing scripts in the Revit projects in the well manner, and painful exports. And based on these answers, we prepared this presentation. So we prepared today's agenda. So we will go through all the steps. We will start from the step 0, which is installing all the Grasshopper inside Revit. So we can call it Rhino.Inside Revit. So this is the first step, and then we are going to show you all the 5 scripts that we have prepared for you, how we can automate the work. So let's start how to set up everything. So maybe you can start a little bit, Jungfu, where to download, which version of Revit you can use, which version of Rhino you need.
So you can use, the important thing is here, Revit need to be installed in advance. And the current Rhino.Inside Revit accommodate from Revit 2020. As far as Revit 2026, you can download Rhino.Inside Revit official release version from the website from there. And then as soon as you install Rhino after Revit, you can install Rhino.Inside Revit. Then when you launch your Revit, and Revit will ask, as always, like as an external add-in, you can enable Rhino.Inside Revit as an additional Revit add-in. You can click on always load, or you can load once, but yeah, if you use actively, you can use always load. Next, please. Then sometimes if your Rhino version is not supported, then automatically you get indication with a message that download latest Rhino, which is supporting Rhino.Inside Revit. Then if this is the case, you can click on download latest Rhino, but make sure you have the license for that version. Otherwise, you not be able to use Rhino.Inside Revit or Grasshopper in Revit. So make sure your Rhino license is up to date. And then if you still have a licensing issue, then you have to contact definitely Rhino McNeil or your IT department. But if you have Rhino license, then you wouldn't have this issue. Next, please. Then in some case, you may have different Rhino version installed at the same time. Then Rhino.Inside kindly asks you which Rhino version you want to active. And there you can see in this screenshot, you can choose Rhino 8, for instance, and it shows the version below which Rhino 8 you have installed. So make sure choose right Rhino version you want to use it. Please, next.
Yeah, and I would like to just add that if you are just starting and you are new to, I would like to just add that if you are new to Rhino, you can download it for free for 90 days for just try it for yourself.
With me? Yeah. Then once you load and launch Rhino.Inside Revit, you still have to enable Rhino.Inside by clicking on that Rhino.Inside ribbon from your Revit, and then you make sure click on Start. Then you can initialize Rhino.Inside Revit within Revit. And you may notice this red dot on the top right corner, which indicating the updates are available for your Rhino.Inside Revit. Then you can click the options and you can choose the update channel, public release version or daily update. So you can download right version, or you can also go release candidate or daily build and click on the release notes to see what's been developing and what's been developed. And you can also test those pre-released version. Next, please.
Yeah, so we went through the setup. Can you hear me, Jungko? Yeah, so just to repeat, if you are new to Rhino and Grasshopper, so you can download educational version and you can just test it for 90 days in working without any limitations inside Revit. Okay, Jungfu, so maybe you can share your screen. We will go to the first point from our agenda. We are going to about structuring the data in the Revit model. So this is something like we would like to start with. So maybe you can tell about what we are seeing right now, Jungfu, and what kind of data we are going to organize.
Yeah. So one of the main pain point we got from the survey is that the repeating task, especially the structural data that you need to use it again and again. And I took the work set, creation of the work set from the Excel data could be useful because when you have a project, especially large and complex project, you may have multiple domain Revit models. Depends on even one architectural model, you may have to subdivide it to different parts and zone. And in this case, you need to have common work sets always work through with all those domain models, as well as also external partners or stakeholders discipline model need to keep the same work set, which helps organizing your model. And also when Revit model becomes complex and large, then usually the performance is really slow. And this work set is one of the best way to turn off. Basically, you can close some of the elements which are assigned to specific work set. By closing them, you can actually save the computation memory, and it enables better performance for Revit. So we will practice this in live. Do you see my screen? Or?
Yeah, you can just open. Let me see. You have to share it one more time. So we are going to switch that.
Yep.
And if you can open, have you opened Revit?
Yep.
Okay. Yes. Let me see. It's loading. So let me see. I have to hide mine. Let me see. I do not see preview. Yes. All right. Now we can see your Revit model. So stage is yours.
Yeah, thank you. So basically, when you start with Revit, and most of the case, you set the work sets, and work set is necessary because you are collaborating with other colleagues as well. Or so at the moment, there is no API we can access to enable work set. So this first step is still manual step that you will create work set by clicking on like work set on the collaborate. When you hit OK, then this file becomes a work shared model. And as you can see, we have here the list of work sets which we can create. So when I hit OK, then here we can set the major work set, and we can also browse that work set table. I know maybe some of you may never use work set or never set before, but this is like typical manual process. When you create work set, you say 01 let's say MEP link or something, and you're always manually creating, and it's very tedious to create all those steps manually. For instance, MEP or fire protection, all these things. And this is like, you have to share this work set enabled file as a template to different team or different even companies. So what I want to automate by using Rhino.Inside Revit, we can actually have a common work set template, say the one table from Excel, which is quite common to stream the Excel file in Grasshopper. So I'm just opening our Grasshopper file here, which you can also download it later. And here, once I enable our Rhino.Inside Revit definition, basically we read here, is this document work shared? And you can see, yes, it is true. And is it detached? Is it central file? And all those kind of file information, documentation information, you can also read it. But the major thing I would like to show here is to read that Excel data. Then we can stream this Excel data information to your Grasshopper, and Grasshopper is really good with that data structure. So you can actually stream out those different input data as a list, and we can create new workset by using Rhino.Inside components called Ensure workset. Then once this is run, and as you can see now, if I go to the workset list, boom, we have all the worksets which comes from the Excel. So you don't have to manually click, and you don't even have to share this file as a template to other collaborators, because the collaborators actually can create the worksets from the beginning using Rhino.Inside Revit, and there's consistent data. So you can save this as an architectural model A or architectural model B and C, etc. And of course, there are a lot. Basically, Rhino.Inside Revit provides you a lot more features. If you creating wall, you can already assign them as a specific work set and etc. But I think this topic is a little bit detailed that we I'm not intend to cover during this masterclass. But the thing I wanted to really show is that yes, we can create those kind of repeating work sets. And if we don't need some of them, we can also delete it. So for instance, I just enabled, sorry, I should have enabled. I'm deleting the specific work set, which I don't need. So here I got, now because it's already deleted, I can lock it. Sorry, was a bit fast. I'll undo the deleting process. By the way, any process you transact from the Rhino.Inside Revit, you can always go back from your Revit command history. So here I'm just going back to the previous steps. And if I come back to Grasshopper, and now if I enable, it was already deleted. Sorry, I'll go one more time. It's just automatically already deleted. So let me recompute. So you can see when I recompute that history that I returned, now we just deleted that unnecessary work set, which was, now if I come and open my workset list, you can see it's much more organized. And only one thing that first initial default workset we cannot really delete, and that's the limitation, but that you can also rename it or move it to delete them and manually delete them, and then move all the elements to new assigned workset. So this is my first contents. I know it's maybe some of you may got confused about workset, but the power here I want to demonstrate is that this data streaming from different Excel, different data as an input, and then it automatically change those info. So if I, for example, let's change to linked civil model 2, and once I change that, and if I go back to my Grasshopper, Rhino.Inside Revit Grasshopper, sorry, and you can see instantly the data is updated. So if I recompute, you can see the model 2 is, we stream out the Excel file, and of course, accordingly, your Revit workset is also updated.
That's
okay.
That's really cool example. Simple one, but it's from the beginning, just showing the possibilities, how you can organize and automate that work instead of clicking. So that was a question: is this recorded? Yes, is this recorded, and is going to be available for 7 days. And after just this workshop will finish, we are going to share all the Grasshopper files and Revit files that we are showing. We are not sharing with you right now, because we would like that you are focused on this presentation and tips and tricks that are shared with from Junko. All right, so let's go to the next one. So this one was about structuring data, and now the second pane was about bulk parameters edit. So how to edit from Excel, we know how to structure data, but how to give also all the parameters.
Yeah. So because it's live, I just have to open again. But by the way, you can always close your Revit document, but just remember that your Rhino inside Revit is still up and running. So you can see if I click on the Rhino is still there, and Grasshopper is also still there, and the Grasshopper definition is still there unless you close it from Grasshopper interface. But yeah, it's just once you launch your Rhino inside, this behave as if it's a Revit plugin. So that's something that you remember. And now I'm just going to open a second example. So here we have a very simple.
Just in the meantime, when model is opening, we have a question from Maria. What happens if you already had elements on some of the work sets? Where do you get the message to move them?
Yeah, if you delete, like there, you saw there is deleting workset components. When you delete and workset, you can always delete, but except the default workset, when you delete, if this command is executed, then Revit will give you a warning message. Elements assigned to this workset, you want to also delete or you want to assign to another workset, and that you can choose the new another workset you want to move them all automatically. And Rhino inside Revit already providing all those components. You can do it automatically.
Mm-hmm. Cool. Let's go to the next example about bulk editing of the parameters. So we have a wall.
Yeah. So one of the thing here, Revit, which I often find struggling to have a correct structured IFC data for the open BIM workflow. Of course, you can create like bunch of project parameter from the shared parameter, but sometimes the manual process is also tedious, and not everyone is allowed to create the contents within the organization. But this topic is more for the content manager or information managers who need to have a consistent information. So when you launch here, there's war, and I want to populate all the parameters, which actually comes from the, again, let's say shared Excel file. So if I open this Excel file, you can see we have a parameter name and the data type, and also the description, which what is dealing with, and also there is also kind of like category where we want to put them. So for instance, this Excel data, sorry, this is the workset, and Excel sheet, I want to populate all those properties at once for this specific use case. So let's open our Rhino inside Revit. And sometimes Rhino inside Revit is difficult when you have only one monitor. Sorry. And yeah, now it's opening. So I'm going to drag and drop our second example here. So what I'm gonna do is, again, I'm going to read Excel data. By the way, there are many Grasshopper plugins that allows you to read, import, and export Excel file. In my case, I use here the plugins called the
It's Pancake. It's Pancake.
Sorry.
It's Pancake. It's Pancake.
Yeah, it's a pancake, like pancake spreadsheet. It is open source. You can get it from Food for Rhino. And all I'm doing is just defining the file path and then which worksheet I want to bring it. And then, yeah, just a little bit of data structure here to filter the data. So let's launch it. So I'm just processing the definition. And here, as you can see, we have data which comes from, as you can see, if I compare with Excel, this first column, name, if I go to the next branch of the tree structure, you can see here our first branch is this column here, data type. And then the third branch here is actual parameter value. I just put it here. So you can see we got information from Excel. And then we just do a little bit of filtering. So I know that there are 4 branches, so we explore the tree to get the branches. And here I'm just searching for the member, which is data type as in text, another member project information or Boolean information, yes or no, and some specific Revit built-in parameter name. And then those information is filtered, and we're going to create Revit's project parameter using those things. So for example, the data type, we can define here already what kind of parameter name we want to create here. As an input, we have 16 names coming from this Excel, which is actually the data type of text. And then we will group them under IFC parameters. This is built-in group in Revit. And we can also give some description about this parameter that we are defining in Rhino.Inside. And we will add this parameter as an instance parameter, not type parameter. In Revit, we have 3 different parameter types: instance type and global parameters. We'll add at the moment as an instance parameter, and we will provide category to the world because we are defining this project parameter for specific Revit entity, Revit category, sorry, mixing up with the IFC entity, but yeah, world category. And then from there, we'll feed this parameter to of the group, which is on the IFC parameter group. So let's take a look. If we look at the result of here now, world, as you can see now we have on the IFC parameters, all those parameters populated. And this comes basically, if you know Revit here, usually you create project parameter by manually clicking and okay, this is project parameter. If it's coming from shared parameter, you can select shared parameter, then you can assign them. But what most of case you manually do here, you have to type name, you know, and which this something goes to which data type you have to define, and then which group you want to assign them. So all this process, we did it with the Rhino.Inside Revit components. And also the data type between type or instance or global parameter, we already define it here. And also which category you want to provide. So this was already all automized from our Excel file as a data input. And then Grasshopper definition here, which we filter those data type and naming to project parameter using Rhino.Inside Revit, and then we feed them all of them into the later sorry, here set project information. Set world project parameters. We specify, we filtering out Revit elements, and in this filtered element we just provide all those parameters we generate automatically from this second step and feed values in. And we can not only element parameter, we can also set the project parameter. So this gets also interesting when we think about project parameter in Revit. If you go to the manage and you have project information, right? And even this kind of information, which is on the project information, we can also provide those kind of information automatically from the Rhino.Inside Revit components. For instance, if I click Rhino.Inside and click Grasshopper, and here we define project, in this case, text is empty, sorry. We feed it as a text, and this is going to be building data, and what building data we want to provide in where, and we will provide its instance parameter on the project information, the name, pset building, common number of stories as a project information we want to provide it. And then the same step, we just feeding into, instead of Revit category, we find out project information, and then we feed as if project information as an element, we feed those parameter and value. So in the eventually in this here, when you look at the Revit project information, you can see P set, property set, building common number of storage as a 3 value we providing. So at the end, all this structural data you can export as an IFC, and then you can verify in Solibri or other IFC viewer, just to assure the quality of your model in terms of level of information. Yeah, that's all for the second example.
Yeah, in the meantime, we have also a question, I think a good one from Rohit. Can we delete unused project parameters using Rhino inside Revit?
Can we delete unused? Yeah, there is a purge component. You can just delete purge. So if that information or parameter is anyhow used, then of course you can delete it. But the purge element component is useful because it's a kind of second security level you can give if there is no value used for specific parameter or elements. Then purge element will delete those cross parameters which you don't need.
And one more question: have you used plugin droots for Revit?
Plugin viewer. Sorry.
Yeah, so droots.
Droots. I'm aware of it, but I haven't used it. Sorry.
Yeah, so Kagan wants to compare to the Rhino Insight. So by the way, we have Jaffe with us, who is helping answering the question. So hi, Jaffe. Jaffe is from McNeil. So really good to see you here. From Bogdan, Jungfu, could you please tell us whether it is possible to export IFC model prepared in Rhino, though the Grasshopper, into the Revit space? That way it can be identified as an articulated category.
Yeah, I mean, as long as your Revit, so it's possible to export IFC model prepared in Rhino through the.
We have more, like for instance, in Rhino, we create a shape, and through Grasshopper, we define this geometry as a wall, door, etc., and export into Revit. Is it possible to perform?
Yes, I mean since Python 3 and also the IFC OpenShell, for example, as an open source library, you can bring into. I mean, in this case, we have to use script editor in Grasshopper. And you can import the, for example, IFC OpenShell library, and the Grasshopper Rhino geometry or Grasshopper geometry you can map to all these IFC requirements, and of course you can export directly from Grasshopper. But of course, there is also many plugins. I think Chris already showed a couple of them.
Yeah, Beam or Visual Arc. So there are plenty of possibilities, even though some of them are for free. So there are lots of different possibilities to export IFC and import.
Yeah, so there are plugins, but main idea here is not about exporting and importing, because I mean, most of case we get IFC model from different stakeholders or parties that I understand. So this we need to link it. But the main reason why we're using Rhino.Inside is not to export or import those specific file format in Revit. Rather, we will evaluate those data and then interpolate those data to be used natively in Revit without export input. So it's more like a data-centric workflow. So I wouldn't recommend to have that extra effort to create IFC from Rhino and bring it to Revit using Rhino inside Revit. Rather, you can import IFC in Rhino if Revit struggles, and then analyze those IFC information through Grasshopper, and then kind of feed those information to Revit elements or creating Revit element direct from Rhino inside Revit with structural data. That may be much more efficient.
Yeah, cool. All right, let's go to the next examples from our list. So we went through structuring the data and bulk editing of the parameters. So let's go to the next topics, and the next one was about direct shape. So direct shapes are really useful for the early stage work. So maybe you can just introduce for some users, some Revit users who don't know what is direct shape.
Yep. So the direct shape is kind of so temporary. Let's say it's good to have a temporary workflow. It's very useful when you have a continuous design change in early stage, where sometimes the complex geometry, anyway, those kind of sketch or schematic design keep changing. So there's no really a strong reason we have to bring those as all kind of native Revit elements. In this case, direct shape is kind of useful because you can simply convert different geometry from points to as far as mesh. So different typology of geometry you can just bring into Revit as a Revit readable element. And you can, of course, feed parameters because the direct shape, we can categorize it as a Revit class, Revit category. Then this enables us very fast and reliable method for complex geometry bring into Revit without strong efforts. And that, of course, without saying that speed and flexibility is really, really matter. But there is, of course, issue with the direct shape. For instance, when you cut section or floor plan, it doesn't bring actual Revit's hatch behavior according to your material assignment. It's because this direct shape doesn't have this function. Of course, you can use graphic filters to override that direct shape element with showing correct hatches and so on. But again, the main point here is bring really fast and flexible workflow in early stage or something complex that you don't want to put too much effort, but simply document it, putting dimension. You can put dimension, you can put annotations, you can also tag it. So these all possible, as well as like kind of spot elevations and spot, coordinates. You can all work as it because it has an ID. But just only in graphical way when you cut, and it doesn't really work well in the graphic visibility.
So let's jump into Revit, so we can maybe show in practice how it works. So let's go to script number 3.
Yeah, the example I prepared is actually very, very simple. It's quite far away from the real world example, but you will get idea how we can actually use direct shape directly in Revit. So I'm going to open third one, Grasshopper, direct shape for speed. So let's imagine here I'm going to enable all of this. Enable the definition. You can think about like we have here point in Grasshopper. Oh. Yeah, you have point from Grasshopper, and we're creating a box. Of course, in this center box we can parametrically change the geometry, right? And because it's a Grasshopper element, and here we can actually move it because in Grasshopper we can like array it and move it. We can do whatever we like in parametric way, and these BREP elements can sometimes you want to just bring those BREP elements from Rhino directly to Revit, and that's simply you can do that. So if I do here and I highlight this element in Revit, as you can see, this is a direct shape. As a default, direct shape classified as a generic model. But you can see we can select, it has ID, it has like kind of Revit built-in parameters. You can also use it, and all kind of Revit behavior is there. But it's just fast implementation. So if I move this location a bit, let's say how far I moved it. So I will put it 15. I'm not even sure the unit what I'm using there in Revit. But then let's have a look here. If I shoot this data down, then you can see this BREF just moved instantly. And you may ask why you do that. Anyway, you can just import Rhino file, or like, you can just do it by importing. But the beauty of this, when I see here, I put just dimension as one of the example. The dimension will assign dimension lines will remember that edge ID of the direct shape. So if I change this back to 30 meter, and obviously it moved, and I just shoot the data, and as you can see, the dimension also changed. I mean, accordingly moved the position, translated, but it kept the same information for that element. So this is one of the reasons why direct shape is still powerful, because you don't lose this relationship with the annotation. But sometimes when you have to really flexibly have to change the quick design changes, this really help you to keep documenting in early design stage. And for one of the example here, we have a box, right, in Grasshopper. And sometimes, like, just to play with it, I populate the points here, and we make this kind of mesh geometry. We could do quadri mesh with Rhino new features. Was it Rhino 7? I forgot. And then you can even subdivide it. So this kind of quadri meshed element can be converted as subdivision. And this kind of geometry to bring, I mean, modeling in Revit will be almost impossible. With help of Dynamo, you can do that. But the Grasshopper is much faster when it comes to geometrical operation, right? And this mesh subdivision, we can also like convert it as a again mesh, and then you can change the density of the mesh. Some reason I don't show the mesh edges, so but here I just enable it, and you can see here we have much more dense mesh, which looks like kind of paper model. But this kind of thing to create it as Revit family is tedious. But direct shape, in this case, if I should, and I'm just going to highlight this in my Revit viewport, as you can see, you have this in Revit as a Revit element, which is nice because you know sometimes when this kind of geometry requires in the project, um, um, yeah, this is like power of direct shape using Rhino.Inside. You can just bring it very fast and get the result quickly, right? And so you can actually not only those kind of surface or mesh geometry, actually even point or kind of mathematical curve, like a nerve curve, for instance, from Rhino, you can just shoot, and as you can see, we have that lines as a curves as a graphic representation. You can bring into Revit. When I was designing some kind of interior shop design, some of the lighting fixtures or curtain, I didn't really want to bring every detail as a surface geometry. Sometimes the line geometry could be good enough to conceptually displaying in Revit, and this kind of direct shape allows us to bring that complex curve line from Rhino to Revit. And I'm going to go to the just enable points, and you can see those points also updating with the new design changes. So this is really powerful things when you use direct shape. And because it is a point from Rhino, but as a generic model, it means we can also populate, like, for example, spot elevation. We can take this vertice ID and we can provide this kind of information, right? And now I'm just going to change some, let's imagine the design changed. Oh, my mouse cursor is, sorry. Yeah, this is since when you do the write, somehow it doesn't let me. I just close and open again. So Grasshopper. And now if I, let's say, change more points, the more points will basically create more element. And in this case, if I again shoot these points, then it updates, but you can see those spot elevation annotates are remaining, right, as it into to the new position. As long as you don't delete them, they are always going to update. But if you, of course, bring less points, then basically Revit will lose those elements. And then if they cannot track anymore that Revit ID, then those annotation also will be deleted. So you need to think about also at the same time Revit's behavior, but this will give you quite good workflow to reflect design changes. And also direct shape, we can also assign as a like kind of specific Revit, not only as a generic model class, but also we can specify them as a like specific Revit category, and also we can assign the material. So here add direct shape type, when we use this one, basically we can also add materiality, and also you can see here the Revit categories were. So means if you want to tag this as a, with using Revit element tag, or there are a bunch of annotation and tagging tools in Rhino.Inside Revit, you can actually tag them as well. And I will just, update all those kind of things. Sorry, the other one was glass and the other one was metal. And basically you can keep updating these design changes using direct shape. So I found this is useful in early stage, and you can imagine like right now it looks like kind of paper model we are playing with it. But if you have either building or interior fit out or even furniture, whatever complex geometry need to be keep updating during your early stage of project, I think direct shape is a great element. And Rhino
Yeah.
said,
And it really makes your Revit model much more faster, because they are compared to families. They are really light geometry. So let's go. Like Jaffe is helping a lot for us with answers, so that's great. Let's go jump to another example. If you can open, let's go. The next one, it will be the families at scale. So what are the benefits of Rhino.Inside Revit for family creation?
Yeah, let's have a look. I'm going to close this example. Give me a second so I can move it to next example. So in the next example, I'll just show, we'll create a steel framing family from actually the step file which imported in Rhino. So I'm going to open this time, first time, not Grasshopper, Rhino inside of Revit. And here, I'm just going to drag and drop the Rhino file, which is prepared. So I'm just bring it here. I'll just open it. So we can match the scale between Rhino and Revit and Grasshopper. So as you can see here, this, when I type what, this is polysurface geometry step file imported into Rhino, and it has some kind of attribute or kind of metadata like layer name and etc. Right? So if I go to check, for instance, its property, it has layer and it's closed solid polysurface, and we want to create this steel framing as a native Revit family. Of course, you can do it in Revit, right? You can do model, you can extrude, you can have a, you can like subtract this geometry using void extrusion, and you can add this kind of stiffness detail in Revit. But sometimes there's a lot of work that if that family doesn't require native Revit's constraints, like to parameterize as a Revit constraints. If it doesn't require, then Rhino inside Revit is a great tool to convert this kind of geometry as a native family. So I'm just gonna show you now here. I go to Grasshopper, and we're going to open. Let me lock the, because when I always do the live demonstration, if I don't lock the computation, then sometimes it crashes. So I just want to explain first what I wanted to do. So we will read Rhino geometry using geometry pipeline. You can also, if sometimes when you import CAD file in Rhino, you get some blocked instances, and Rhino is Grasshopper is really great to even read all this kind of block instance using Rhino 8 components. But today what I'm here showing is just purely geometry via pipeline from Rhino to Grasshopper. And then, you know, like when you create, let's go back to the Revit first. When you create family, right, you go to the new, and we have to create family and bring the specific family template from your standard. I'm just going to open maybe generic model family template. And what you do in here is basically you have origin based on those two reference plane, and then we create the geometry. I haven't made a family for such a long time, but anyway, we just extrude something, and then here you define this kind of metadata. You can define subcategory, and of course, if there is no subcategory, you go to manage, and on the object style, you create new subcategory, and you, if this is the right one, then you assign this subcategory to that new one, and you can also define if it's solid or void and giving materiality, as well as all kind of this kind of manual work. If your team require this geometry need to be constrained by Revit's behavior and then need to be parameterized based on all this Revit thing, then of course building family from the scratch in the Revit family editor makes sense. But as I said, if you just have the detailed geometry that really just use it as a family in Revit without specific geometrical changes, but just would like to feed all kinds of attributes like related to this still framing in terms of information, level of information. If you want to feed higher level of information, Rhino inside Revit is really great. So we're going to have a look how we can do that. I'm going to close all this Revit family template. So coming back to Grasshopper, we will set here family category, and we will use that referenced geometry as a BREP geometry that we can create Revit geometrical elements here, and we can also set the visibility if it's gonna show in floor plan or section, what kind of level of detail in view visibility setting in Revit we can define. So all this kind, and also we want to create symbolic line from 2D that not just 3D elements projected to the XY plane. We want to actually create new symbolic line from the Grasshopper and use that symbolic line as a 2D representation of that specific family. So we can here define new visibility. If this detail line shows in the coarse field, yes, but medium and fine, we don't want to show. You know, all this kind of family creation, which Rhino inside Revit has very detailed components that you can really create the roadable family with all this kind of detail. And again, and we can also set the materials as well as all the parameters, right? So let me launch this. So I'm just enable it. So now we can see, because this subcategory beam for is already in some of the, because the example it was already exist, and it shows that as a warning. but it's not the error. What we're gonna do is from the Grasshopper, we read this geometry, which we have in Rhino, and this one we're going to convert it as a VREP. And now, as I said, we need to create kind of 2D representation. So what we do is here, just using Grasshopper, make 2D components, native Grasshopper components that we can compute. So I want to specify particular view, which is top view of Rhino. So this view as a kind of line representation. So what I'm gonna do is we're going to compute the top view and make it as a 2D. So once you compute, we have all these make 2D lines, but this is always placed somewhere in the middle of your viewport, and I want to align these lines to the geometry, so we have our same coordinates. So what I'm doing here is just a bit of Grasshopper logic, and at the end, as you can see, we have here the line drawing, which is aligned to the 3D geometry position. And this 2D line will be again specified with a specific subcategory name and then converted as a family curve. And this family curve graphic style, we can choose between projection and cut. It's same as all Revit family creation info. And this we will override it. We will create as a my beam and as a structural framing family. And then we can, once this is created, family is already created, and this my beam family, we just locate it into Revit documents by using add component from Rhino.Inside. So you can see whatever we create from Grasshopper, now this is placed in Revit, yeah, as a family. So if I go back to my Grasshopper definition, I'm going to lock this one. I'm going to lock. And if I just edit this in family editor, you can see geometry is kind of actually explosion of step file input kind of thing. But here, if I go to, for example, floor plan, and let me change this level of detail. So if I go to medium or fine, then actually 3D elements visible. But if I go to the coarse field, 3D elements is not there, but we have this 2D line, which is assigned to structural framing, and as a symbolic line, we have this 2D line to just display in floor plan view. So all this out, like basically 2D line and 3D model geometry came from Grasshopper, and that this family was loaded into Revit document based on your Rhino coordinates. So Rhino coordinates, Grasshopper is knowing unit and coordinates referred to your Rhino coordinates, and this was just dropped. We just dropped in. Of course, you can shift it, you can move it, translate this position of origin, but this family type is edited into your Revit document in Revit 1. And later we can also provide more like parameters and the value. For instance, here I want to provide this element components family as an element, and I want to feed those parameter with a value. So if I go and I'm going to select this Revit family, and as you can see, this built-in parameter to classifying your Revit element as a IFC element, it's already mapped according to your Grasshopper definition. So you don't have to manually go here in the table, choose things like that. You can just directly feed those information from Rhino Inside Revit. It's already a big step to automate.
I can imagine it can help a lot and save a lot of time if instead of creating families from scratch.
Yep.
All right, times flies, so we have to jump to the next example, and the last script that we would like to present. It's about automating the views and sheets and drawing creation. So Rhino.Inside Revit can automate the creation of the views and all these repetitive tasks with the revision, placing views, applying templates. So we have prepared really cool examples. So can I share your screen?
Yep.
So yeah, we have a bridge. So there was a question if we can create parametrically bridges and culverts. Of course, Grasshopper is great for that. And Jungfu will show how to create drawings from that model.
Yep. So in this example, the geometry, it was created from sophisticated bridge model components of the Grasshopper definition. But this I don't intend to show here in this masterclass. But let's imagine you are a BIM coordinator or BIM element author, who actually don't care anything about whatever geometrical changes from first engineering's input, but you want to stream those engineers' design as a data pipeline out of the Grasshopper, then this data input could be very useful, and you can only focus on your BIM process. So what I'm doing here, I'm using data input components, and you can define the source from the data output of, let's say, Bridge Designer. And Grasshopper, sorry, maybe I have to explain that. In Grasshopper, you can have data output, and anything you want to feed as output data of your Grasshopper definition, you can provide here. Doesn't matter graphical or non-graphical information. It can be geometry, it can be any attribute. You can name it how you want. And once you have defined your data output, you can set destination to save as Grasshopper data output file, which is the extension of GH data. And this, you don't have to send the Grasshopper definition. You can only send this file to your collaborator. In my case, the bridge designer already designed bridge, and they want to just share the geometrical information of bridge to the BIM element author, and BIM element author just selecting this Grasshopper data file. And once you enable this, it may take some time because we creating a bunch of things here.
By the way, in the meantime, I got a question before this workshop about revisions. Can we make changes of revisions of the drawings through Rhino.Inside Revit?
Yeah, it has a native revision components that you can do all kind of revision things that Revit allows. Yeah, there is a revision component.
Mm-hmm.
I'm
anyways,
sorry, this takes some time.
I'm
Usually
impressed.
when I
I'm
share my
impressed that it
screen,
was the first time. I'm impressed that it was the first time.
actually,
so
those shouldn't take this long, but yeah, it's in Drive always happens.
yeah,
Sorry about that.
never mind. Maybe
Any
we
other
can
question,
jump
please? In the meantime.
Yeah, maybe we can jump to another point in the meantime. Okay, so so we can just go to or we have some error.
This kind of Grasshopper message. Just yeah, let's jump in some other.
In the meantime we can jump to another one. So one of the problems was how to make exports and imports and how to make it easier. So Grasshopper is really great because we have 50+ live link connection with the AAC software. and Rhino and Grasshopper can read more 49 different files formats. So this opens lots of possibilities for importing and exporting. I made the lists of the BIM software, of the finite element software, of the visualization software that can be connected, and we are going to share with you this presentation. You can also connect to Speckle, to Power BI, some cool examples how you can visualize data in Speckle through Grasshopper and using Power BI. It gives a lot of possibilities, and this is one of the most powerful and advantage of using Grasshopper instead of Dynamo, that gives you a flexibility to connect with software that you're already using. We had some workshops about connecting Revit with the finite element software. Like in this example, we have SAP 2000, and we could use Rhino.Inside Revit to create directly from finite element software elements into Revit. So we took elements from SAP 2000, which was created through Grasshopper. So we had this our central model, and then we connected towards finite elements words and Revit words. The same other software, in this case, it was safe. The same if you would like to transfer some data about slabs, about some geometry from first Grasshopper to Revit, or also other way around. If you modeled it manually in Revit, you can get it to Grasshopper and Rhino, and then export it to safe. So it gives you this two-directional connection. So let's come back to the views and sheets. Maybe you can share your screen again, Jungfu.
Yeah, sorry, I on purpose stopped sharing because it computes much faster. So, sorry, man. Give me a second. Do you see my screen?
Let me see. We're going to add. Just waiting a second. Yeah, we can see it right now. Okay, you can continue.
Yeah, thanks. So when you define that designated Grasshopper data file by just clicking source and bring it into this data input, then this output will be automatically pop up based on the data output which bridge engineer or designer sent to us. So like tendon center lines, tendon geometry, support points, and all the peers, all this kind of thing comes as Grasshopper data now. And as a BIM, let's say I'm BIM element author, that I just need to care about my Revit model to be readable. So what I'm doing here, we just again revise of the direct shape. So I was interested in, for example, the information of like the major cross sections and also the center line of pier, as well as the bridge axis. So this I would like to still represent it into my Revit model, and also the pier points that that I can annotate. I would like to also, populate as a geometry. Then, as you can see here, we have those direct shape. So I can select, for example, generic model here, representing generic model. Sorry, it's slowing. I just isolated actually.
We are also on the stream, so that's why maybe it can be a little bit slower.
Yeah, so you can see that line, which I wanted to show as a kind of direct shape as a generic model in Revit, is also here. Do you see my screen, Chris, by the way?
Yes, we can see Revit.
Yeah, Revit screen, you see it, right?
Correct.
Okay, good. So I'm just going to, coming back to entire viewport. So yeah, I see this definition is shouldn't be heavy, but when I'm streaming, it looks like a little bit struggling to show. But actually, this is not the issue of Rhino.Inside Revit's performance. It's more rather the issue of the streaming. Okay, so let me go back to my Grasshopper definition. And so we convert data output as a direct shape here, just to reference how the bridge is constructed. And then what I'm gonna do here is also we will convert all this actual 3D geometry as a native loadable family. So I'm predefining here material, tendon, pier, superstructure, railing, and that defined material from Rhino.Inside Revit will feed assign those material with correct family name. This is just typical Grasshopper data manipulation, changing the data format to rename them. And also there is a little bit of rework that I'm just getting the edge line of this bridge superstructure, and along those curves, I'm just generating this kind of handrail geometry using Grasshopper. So we have right side and left side. And this, I would like to just generate them as a railing component, but in this time is as a roadable family. So this is another family we're just generating into Revit. And those pier and the bridge components like superstructure, they also created as a family and then load into the project. So at the end, your result, what you get as a Revit, you have this geometrical elements as a native Revit model, and they have a correct category. This is not no longer direct shape, rather this is actual Revit family, so you can actually edit. So if I go to manually in my floor plan, if I generate section here manually, then you should get the native, just typical Revit section drawing. I'm just struggling to presenting in live. Sorry, but maybe I should have recorded this one as a video. Sorry, it's live. It's always a bit taking time. So it's just section drawing. I go to the view, and you can see this show, because it's not anymore direct shape, you can actually get correct line weight according to your object styles in Revit and the hatches and all kind of behavior. But the beauty of it is that you have correct category and all kind of, you can feed parameters, instance and type parameters accordingly, and then you can document in Revit, right? But what I wanted to do here is actually, I would like to create all the sections that has some interval along the bridge axis, and then generate all those view automatically from the sections automatically generated by Rhino.Inside Revit, and place them into title block automatically. So let's have a look what I'm doing with the Rhino.Inside Revit in the next part. So we're going to have extract basically the bridge axis. Here we want to divide it to 30 division, so we can use those division point as placement of the section view, and we just generate again. Maybe I don't need to explain all this detail, but basically what I'm gonna do is I'm going to generate all the bunch of box that shows the depth of the section. So from each point where the bridge axis is divided, and from that point we will give the depth of view depth for each section lines, and this domain box can do that function, and then we will create a bunch of sections according to those frame we if I go to that, those
Yeah,
frames.
maybe we don't have to go too much into that details. Maybe we can just show the results at the end, how it can save time for Revit users at the end stage.
Yep. So let's imagine we created all the sections and the view range. Yes, it's true. It's a lot of things here. We providing view range of sections and creating sections, and then accordingly we construct the viewports of each position, and we will add all of them into the drawing sheet. And of course, the sheet will be generated using Rhino.Inside Revit. So if I go to the you can see here a bunch of sections generated from Rhino.Inside Revit components. And if I go to that sheet named to 102, if I double click, yeah, you can see all these each sections along the bridge axis automatically placed in the sheet. I don't have title block here. I didn't put it, but you can imagine this is a sheet, and you have all the views populated in your drawing sheets, and you can
make it
so this
with
is
not
like
just
really
bridge,
powerful things when you use Rhino.Inside Revit. And because the geometry keep changing, and it has kind of reference to those kind of control point and geometry, and as long as those points are not lost from big design change, whatever you annotate will be keep updating in the future also. And here in this masterclass, we didn't cover how to reference those Revit's vertices or edges and surface as a dimension reference, but actually you can even automate the dimension process using Rhino.Inside Revit, which is a little bit tedious because you have to always reference the constructed Revit element, not Revit elements, but Revit geometry of Revit elements, such as vertices and edges and surface, face. But if you have structured pipeline, it will work, and those dimensions will be also always updated accordingly.
And this is what we are showing in our